All right, today we're going to talk about congruent triangles. Congruent triangles have to have 3 congruent sides and also 3 congruent angles. And don't forget that this is the congruent sign. Congruency. All right, let's draw a picture that shows that triangle ABC is congruent to triangle DEF. Then put tick marks on all the corresponding congruent segments and arcs on all the corresponding congruent angles. So let's just draw 2 triangles. They're close to each other. So the important thing is to make sure that we label in the same order. So ABC corresponds with DEF. And we can start just putting tick marks on each one. So I know that angle A corresponds with angle D. We can also see it up here in the notation. That angle A corresponds with angle D. So the first one, we have angle A is congruent to angle D. And we also have angle B is congruent with angle E. And angle C is congruent with angle F. Okay, we also have 3 sides that are congruent to each other. So AB is congruent with DE. So segment AB is congruent to DE. BC is congruent to EF. And segment AC is congruent to DF. Okay, let's go on to this page. So again, we have triangle ABC. I'll make it a little bit larger. Is congruent again to DEF. And I'm just going to label what we know. So I know that segment AB is equal to 5x plus 7. Angle BC is equal to 7x minus 3. And AC is 4x plus 5. In addition, segment EF is equal to 10x minus 15. Now we can see that the only thing that corresponds with EF is 7x minus 3. So I can set up an equation and solve for x. So I like to keep the larger variable at first, get rid of the smaller one. So we have negative 3 equals 3x minus 15. I'm going to add 15, add 15. So we get 12 equals 3x. And divide by 3. And we get that 4 equals x. Now I can take that value for x and plug it in. So we have 5 times 4 plus 7 equals 27. So I know the corresponding side also is also 27 because we need to find the perimeter of DEF. And we do know that the AB is corresponding with DE. Okay, now I know that I'm going to plug in here. I have 7 times 4 minus 3 equals 25. So this equals 25. And the last one we have is 4 times 4 plus 5 equals 20. So this equals 20. So I can add up the 3 sides for our perimeter. Is 72. So the perimeter equals 72. So the next problem we have is just to find out what congruent statement below is correct. So if you notice that all the triangles on the left side, they all start with D. So I'm just going to go look at D. Right away, I can see that that corresponds with E. So the only one where I have D and E, D matching up with E is right here. So that's going to work, and so is this. So the next vertex we have is F. We have DFA. So I look at F, and F corresponds with C. So only one where I have F going to C is right here. So it has to be D, because we have both of those corresponding. So the answer is D. Triangle DFA is congruent to triangle ECG. So I have 2 triangles, QRS and QRT, which are congruent to each other. I can see right here that we have a common side. So I'm just going to take this and make it a common side. So I have QR. Now my other triangle on the left, we have QRS. So QRS, I'm just going to put an S out here and just complete their triangle. And if I have QRS on the left side, I have QRT on the right side. I'm just going to put that there. So we have a triangle QRS and QRT, and QR is a common side with each. So I'm going to start with the angles. So angle S, we can use just one letter here because that vertex is only assigned to one angle. So angle S is congruent to angle T. Let's go up here. So I'm going to use this angle right here. So angle SQR is congruent to angle TQR. And the last one we have is here. So I have angle QRS is congruent to QRT. So we're done with the angle, so let's look at the sides. So I know that the side of SQ is congruent to QT. So I can take segment SQ is congruent to segment QT. Segment SR is congruent to segment RT. And we have a shared side of QR. And I'm just going to put 3 tick marks there showing that that is congruent. So we can use QR is congruent to RQ, or you can also use QR, it doesn't matter.